As assigned in class today, your task was to take the equation given, f at x equals x minus 2, and all of that divided by 3x plus 4, and to graph it. So as per the domain, when dealing with these types of functions, we have to consider restrictions on the domain. So those restrictions would be specific to points of discontinuity and or vertical asymptotes. Okay, so thus far, let's start with thinking about restrictions. Okay, so for f at x, which is equal to x minus 2 over 3x plus 4, recall that the denominator cannot be 0. So this is our restriction that we must place on the function. So specifically, what that means is that this implies that x cannot be minus 4 over 3. So if we solve the equation, 3x plus 4 equals 0, we would determine that the value of x is minus 4/3. So with that being said, we can now come back to addressing the domain. So therefore, the domain of our function f, okay, would be the set of all x values belonging to the real number system such that x cannot be minus 4/3. Okay. So next we'll deal with the x-intercept. And for the x-intercept, recall that the 0 is determined from the numerator of the function. Okay, so wherever x minus 2 is equal to 0 is where the 0 will be for the rational function. So x equals 2 is the function 0. So far we know about the domain. We have the break in the domain. We know the 0. So let's move forward a little bit more. The y-intercept, in this case we set x to 0. So we'll determine f at 0. So substituting in 0 for x, it looks to be that we'll have minus 2 over 4 or minus 1/2. The VA, we've already figured that out, right? On the previous page, we determined that the VA is x equals minus 4/3. I'm just going to double check the sign on that answer. Yeah, that's exactly what we wrote down. And last but not least, we have the horizontal asymptote. So recall that for all functions f at x equal to ax plus b over cx plus d, the horizontal asymptote is given by y equals a over c. Okay, so thus our vertical asymptote, in this case y equals a over c, is going to be equal to, let's check our function equation out, and here it is. We can see the a value is 1, so our HA will be 1 over 3. Last but not least, let's determine the positive and negative intervals for the graph. Okay, because we can plot the zeros, the y-intercept, we can know where the asymptotes are, but oftentimes we need to figure out where's the function positive, where is it negative, and by knowing this, we can properly graph the function. So underneath this poll tab, what I'm going to do is show to you a listing of the critical values. Okay, so remember that 4/3 minus 4/3 was the equation of the VA. 2 was 0, right? So what we want are x values less than the VA. We want to examine what the sign of the y values will be in between the VA and the 0, and then we want to observe the sign of the y values for values that are greater than x equals 2. So it's very much similar to the types of tables that we were constructing in our unit involving polynomial functions. So what we'll do is let's take the numerator and the denominator. We will choose a value in each interval. So for instance, if we were to choose, say for instance, a value smaller than minus 4/3, let's take minus 2, for example. So if we use minus 2, we can see how these values will be negative. If we then test a value between minus 4/3 and 2, let's say we use 0, then we can see how this one would be negative and this one would be positive. And last but not least, let's test the final interval, that is x greater than 2, and we'll choose any old value. Why not 3? So by using 3, we can see how the signs are positive. In the end, as opposed to multiplying, rational functions tell us that we need to divide the numerator by the denominator. And in doing so, we can see how the function's values vary with respect to the critical values that are given by the VA and the 0. So now we're ready to sketch this thing. And before we do so, let me just make sure what I've got here. I had just forgotten and or omitted to pull this out. Okay, I mentioned a lot about the critical values or specific intervals. Here's a bit of a snippet from your text that shows us how we would divide the domain into these 3 intervals. And from these intervals, we test for the sign of the various y values and use them to make our graph. So last but not least is for you, for I, to take all of those critical values and to plot them along with the asymptotes. Consider the signs where the function's positive and negative and complete the graph. So for the purpose of time and in saving time in graphing, I'd have you pause the video, either attempt your graph or check your graph based on what you've already seen, and then play the video on, because what you'll see then is a key or an answer key specific to this particular problem. So here is a representation, a graphical one, of what we have just completed. So if we take a look at this thing, we'll take note of some of those characteristics. You can see our 0 is here. Also take note that we do have our y-intercept here at minus 1/3. Sorry, not minus 1/3, but we have minus 1/2. And then we also have our horizontal asymptote. With that information in mind, now also look at the regions where the function is positive and negative So we tested values that were less than the minus 4/3, right? We tested values that were less than that, and we ended up with positive y values. We then decided that we would look in between minus 4/3 and positive 2, and the function values are negative in that region. And then anything that goes beyond, right, beyond positive 2, we tested it and saw that the function was positive. And there's only a very small region where that happens, and it's right here. In between the HA and the x-axis, do we see those positive values again? So I'm just going to clear the ink from this slide to demonstrate another way that you can complete the graphing. Let's clear ink. What you can do is once you've determined this information here regarding your intervals, another way to tackle the problem is to highlight the areas where you would not expect to see the function. That could even be done prior to graphing the 0 or the VA. Well, actually, you do need the VA in there to do so. But take note of these areas here, right? All of these areas will not be used in the graphing of the function. So by crossing them off, it limits the field that we need to look at, and then helps us to decide where the function is going to end up. Right? So in closing, your next opportunity to learn was given out in class. It was mentioned that you focus on this video and try to work your way up to 9, and that we would reassign the final 2 or 3 questions in our next class.